So you did it. You dropped a ton of cash on a powerful graphics card expecting your games to run smoother than a fresh jar of peanut butter. But instead, you're still getting these annoying stutters that make you want to rage quit reality. Well, your hardware can be the problem, but a lot of the time, the real culprit is hiding in plain sight: your settings. Most GPUs ship with default settings designed for power savings and compatibility, not maximum gaming performance. That means your GPU can sometimes throttle or behave unpredictably right when the action gets intense, causing those frustrating frame drops. The good news? You don't need risky overclocking or complicated tweaks, and in this video, we're going to change a few key settings that tell your PC when a game is running, performance comes first. Let's get into it. All right, so the first thing we're going to take a look at is NVIDIA Control Panel. This is basically ground zero for how your GPU behaves, because driver level settings can influence or sometimes even override what a game tries to do. So right click on your desktop, scroll down to NVIDIA Control Panel. You want to click on Manage 3D Settings, then go to the Global Settings tab, and then scroll all the way down until you see Power Management Mode. So by default, this is probably set to optimal or normal power, and that's great for saving electricity, but not great for gaming. What this setting does is it allows your GPU to downclock when the workload drops. The problem is that games constantly change workloads, so one moment nothing is happening, and the next moment a big explosion or a crowded fight hits the screen. When the GPU has to ramp its clocks back up, that delay can cause micro stutters. So let's go ahead and change that. So click on this. If it's on normal, go ahead and change it to prefer maximum performance. This keeps your GPU running at higher boost clocks during gameplay and can significantly improve 1% low frame rates, which is what makes games feel smooth. Bottom line, we want consistent performance, not power saving. Next, we're going to go ahead and find low latency mode. So if you just go up a little bit, you'll see low latency mode. And we want to go ahead and set this to on globally. And what this does is reduce the number of frames the CPU prepares ahead of time for the GPU, which helps lower input latency and can make the game feel more responsive. Now you may notice if you click on this to change the setting, there's a setting called Ultra. That setting tries to be even more aggressive with frame scheduling, but using it globally can sometimes introduce stutter, especially if your GPU is already under a heavy load. So now that we've changed low latency mode to on and power management to prefer maximum performance, all you have to do is click apply for the changes to take effect. And next we're going to talk about NVIDIA Reflex. If a game supports Reflex, you'll usually see it in the game's graphics settings as Reflex on or Reflex on plus boost. You can leave low latency mode set to on globally, even if the game has NVIDIA Reflex. When a game supports Reflex, the game overrides the driver setting automatically, so the control panel setting basically becomes inactive for that game. So nothing breaks if it stays on. For games like Destiny 2 that bounce between CPU and GPU bottlenecks, I usually recommend Reflex on plus boost to keep the GPU clocks high and reduce latency spikes. So let's go ahead and change those settings. Press F1, go to the settings cogwheel, go to video, scroll all the way down until you see NVIDIA Reflex, and it'll have arrows where you can change the setting. So again, on plus boost, you can hit enter to apply the setting and escape, and you're good to go. So another example for competitive games would be Valorant or Counter-Strike 2, which are often CPU limited, meaning the GPU isn't always fully utilized. And in those cases, on plus boost helps keep the GPU clocks from dropping when the CPU becomes the bottleneck, which helps keep latency lower and gameplay feeling more responsive. On the other hand, games that are heavily GPU bound, like Cyberpunk or Red Dead Redemption 2, are usually already pushing the GPU close to 100% usage. And in those cases, just using Reflex on is typically enough because the GPU is already running at full speed and boost doesn't add much benefit. So a good rule of thumb, if your GPU fluctuates or drops, use on plus boost. If your GPU is already maxed out most of the time, on is usually all you'll need. Next up is shader cache size. So go ahead and right click on the desktop and click on NVIDIA Control Panel again. And we're going to click on Manage 3D Settings, go to the Global Settings tab, scroll all the way down until you see Shader Cache Size. Now, if you ever notice how sometimes when you enter a new area, trigger a big explosion, or see a new effect for the first time, the game suddenly stutters, a lot of the time, that's because the game is compiling shaders in real time. To help out with that, you can increase the shader size to something larger like 10 gigabytes or even unlimited, which I have for my current setting right now. This gives the driver more room to store pre-compiled shaders so they don't have to constantly rebuild them while you're playing. Now, this won't fix every game. Some game engines just have shader compilation issues, but giving the cache more room can definitely reduce those random hitching moments. Next, we're going to find texture filtering quality. So if you look down from shader cache size, you'll see texture filtering quality. We're going to go ahead and change that from quality to high performance. So you can click on it for the drop down menu. If it's on quality, change it to high performance. And what this does is reduce some of the driver level filtering work the GPU has to perform when sampling textures. In fast-paced gameplay, the visual difference is usually extremely hard to notice, but it can reduce a bit of driver overhead, which helps free up GPU resources for actual rendering. Now, you won't see a massive FPS jump here, but it can help smooth out performance slightly, especially in games where the GPU is already working hard. So essentially, you're trading a tiny bit of texture filtering precision for more consistent performance. Finally, let's talk about vertical sync or VSync. So if you're on texture filtering quality, just scroll down a little bit till you see VSync. And what we're going to do is we're going to turn this off globally. So you can click on that. If it's on, just turn it off. And traditional VSync works by forcing your frame rate to match your monitor's refresh rate. The problem is that it can introduce noticeable input lag, which makes games feel less responsive. Instead, there are better options. If you have a G-Sync or FreeSync monitor, use that. That's the best solution for smooth gameplay. So let's go ahead and apply these settings. It's going to take a little bit. And next, we're going to set up G-Sync. So set this up on your primary monitor only, not your secondary monitor, but you want to click on that, your primary monitor, and enable G-Sync. Also enable for windowed and full screen mode, and then enable settings for the selected display model. So you're good to go there. And finally, you want to check the refresh rate and make sure it matches your monitor's highest refresh rate. So it's 144 here. To double check it, you can right click on the desktop and go to display settings, scroll all the way down to see advanced settings, and currently it's on my secondary monitor. We want to change that to the primary monitor, and you can see it matches at 144. Now, if you don't have adaptive sync, it's usually better to use your game's built-in frame rate limiter rather than relying on driver level VSync. The key idea here is simple. We want smooth frame pacing without adding extra latency. And here's how you change your game's FPS cap based on your monitor's refresh rate. So go ahead and press F1, go to the settings cogwheel, go to video and turn off VSync. You see right here, scroll down, turn off, and then frame rate cap enabled, turn that on. And frame rate cap for me is 141. So if your monitor is 144 Hertz, cap your FPS around 141. And on screen, you'll see more examples of how to cap your FPS. And once you do that, hit enter and then escape. Keeping your frame rate slightly below your refresh rate allows technologies like G-Sync or FreeSync to work properly and prevents VSync from activating and adding latency. The result is smoother gameplay and more stable frame times, even if the FPS number itself is slightly lower. And that's it. If your games were stuttering before, chances are your hardware wasn't the problem. Your PC was just running on safe default settings. With a few quick tweaks, you've now told your GPU to prioritize performance when it actually matters while you're gaming. If it helped, like and subscribe. I've got more optimization guides coming. Also, drop a comment letting me know which game finally stopped stuttering. GG's, and I'll see you next time.